You know, we've all caught them on our tongues or watched them pile up outside our windows. But have you ever really looked at a snowflake? I mean, up close. They're not just bits of frozen water, they're these tiny, perfect little masterpieces. So today, let's unravel the incredible mystery of how they're actually made.
Right. These are the two big questions everyone asks, aren't they? And the answer is, well, they involve a wild journey through the upper atmosphere, where physics and chemistry get together to turn a microscopic speck of dust into a perfectly symmetrical jewel. So, let's follow that journey.
So where does a snowflake's life even begin? You might think it's just a frozen raindrop, but the real story is actually way smaller than that. We're talking about a single mote of dust and the fundamental laws of how molecules work.
Okay, before we go any further, we got to get a key term straight. Scientists are pretty specific about this. They call this a snow crystal. Now, what we usually call a snowflake can be a single crystal like this, or it can be a big clump of them all stuck together. For this explainer, we're really focusing on that single, perfect crystal.
Every single snow crystal has this kind of four-act life story. It all starts with something called nucleation. This is where a bizarre thing called a supercooled water droplet, that's water that's below freezing but somehow still liquid, grabs onto a speck of dust and finally freezes. Then comes the growth phase, where water vapor in the air crystallizes directly onto it. But the most important act is its journey, this chaotic fall through the sky that carves out its unique shape. And believe it or not, even on the ground, the story isn't over, as it slowly changes in a process called metamorphism.
And this is a really crucial distinction to make. Sleet, that's just a frozen raindrop. It was liquid water first. A true snow crystal is something way more magical. It's born directly from water vapor, a gas, turning straight into solid ice. So these intricate, beautiful things were never even liquid water to begin with.
So, why 6 sides? It all comes down to the water molecule itself. The way its atoms are angled basically forces them to bond together in a hexagonal grid when they freeze. So that tiny, invisible pattern at the molecular level is what creates the beautiful 6-sided shape that we can actually see.
Okay, so that hexagonal seed is set by physics. But how does that simple little hexagon blossom into such a complex, beautiful star? Well, that all happens during its fall from the sky, a kind of chaotic ballet dictated by the constantly changing weather inside a cloud.
This amazing diagram, this is basically the secret key to the entire mystery. It was developed way back in the 1930s, and it's kind of like a recipe book for snow crystals. Along the bottom, you've got temperature, and going up the side, you've got humidity. By mapping these two things, you can pretty much predict exactly what kind of crystal is going to form. Let's break down what that means.
I want you to think of the falling crystal as this tiny probe passing through all these different weather zones inside the cloud. Temperature sets the basic shape. So a little warmer, around -6°C, and you get these long needles. Get colder, down to -15°, and you get flat plates. At the same time, humidity, which is really just how much extra water vapor is in the air, decides how complex it gets. More vapor means more intricate, beautiful branches.
You can almost think of it like a battle between two different growth strategies. On one side, you have faceting. That's the tidy, orderly forest trying to build smooth, flat surfaces that follow that original hexagonal blueprint. And on the other side, you have branching. That's the wild, chaotic force, where the corners poke out, grab more moisture, and just grow these crazy tree-like arms. The final shape we see is the result of this constant tug-of-war.
And this brings us to what is, for me, the most mind-bending part of the whole story. If the crystal shape is determined by this random, chaotic journey, then how on earth can all 6 arms look so perfectly identical? It seems impossible, right?
I mean, how do the arms talk to each other to make sure they all grow the same way at the same time? Is there some kind of mysterious force at play, some secret code passing through the ice?
The answer is so beautifully simple. Nothing does. The 6 arms don't communicate at all. They grow completely independently. But because a snow crystal is so tiny, just a few millimeters across, all 6 arms experience the exact same changes in temperature and humidity at the exact same moment. They grow in perfect sync because they share the exact same life story, second by second. And here's the final twist. You know that perfect symmetry we just explained? It's incredibly rare. The postcard perfect snowflakes are basically the supermodels of the snow world. Most crystals that actually reach the ground are lopsided or broken or just kind of messy. Nature isn't always as neat as the photos make it seem. In fact, get this, some studies suggest that only about 1 in 1,000 snow crystals reaches the ground in that picture-perfect symmetrical state. So the ones we see in pictures and celebrate, they're the rare survivors of a very, very turbulent journey.
So now that we understand the rules of the game, temperature, humidity, and that idea of a shared journey, let's just take a look at the incredible, jaw-dropping variety of forms these simple rules can create.
So here you can see two extremes. On the left, you've got a simple hexagonal plate. That's what you get in low humidity. But look at the one on the right, a super complex fern-like dendrite. That one took a journey through some very cold, very moist air. It's the same water, but totally different life stories.
And this whole process is unbelievably sensitive. The long, slender needle on the left formed at one temperature, while the broad star-like plate on the right formed at a temperature just a few degrees different. Each crystal is like a tiny, perfect thermometer, recording its entire journey down to the ground.
And sometimes, a crystal's journey is especially dramatic. This thing is called a capped column. It started out growing as a column, but then it fell into a different temperature zone that favored plate growth, causing these flat plates to form on both ends. It's like a tiny barbell, a perfect record of a change in altitude and temperature. And while that six-sided rule is pretty fundamental, nature always has exceptions up her sleeve. Under very specific and really rare conditions, snow crystals can even grow in a triangular shape, a fascinating variation on the hexagonal theme that we still don't fully understand.
So after this whole journey through physics and chemistry, we can finally step back and appreciate the big picture. What's the ultimate secret behind the snowflake's endless, intricate art?
It's really this, a few simple physical rules. The way water molecules lock together and how their growth responds to temperature and humidity can generate a nearly infinite variety of complex and beautiful forms. There's no blueprint, there's no genetic code. It's just spontaneous order emerging out of chaos.
Henry David Thoreau captured this sense of wonder just perfectly. Each snow crystal is this fleeting testament to the elegant physics playing out in the clouds high above us. So the next time it snows, take a closer look. You're not just seeing frozen water, you're seeing the history of a journey, a story written in ice.